Hi everyone, good evening. Welcome to Gnan Cloud Garage. In this session, I'm going to talk about ESXi deep dive troubleshooting. So agenda troubleshooting tools importance, ESXi architecture and ESXi architecture components, ESXi log files, ESXi commands, and how to monitor and configure ESXi server settings, and how to monitor core ESXi performance and ESXi troubleshooting frequently used commands and ESXi configuration files. So troubleshooting tools importance. Let's start with the troubleshooting tools importance. So troubleshooting tools importance is knowing how to use the tools available to troubleshoot the system issues can be extremely helpful. And the GUI, graphical user interface, the command line and log files can help in troubleshooting of problems when diagnostics are not enough. Okay, and as we are aware, uh, digital proverb is even the simplest tools can empower people to do great things. Okay, and troubleshooting tools importance continuation topic is to improvise troubleshooting steps we must understand the ESXi architecture from a component breakdown perspective. So we have to understand the ESXi architecture first, and then troubleshooting the ESXi very much same as operating system, any operating system, and starting by narrowing down the component which is causing the problem. And here are the key learning objectives. So first I will cover the ESXi architecture and then architectural components, and followed by ESXi log files and then ESXi commands, and finally we can close with the ESXi configuration files. The importance of architecture is it will give you the complete big picture of ESXi operating system, and also we should learn about each and individual components in ESXi operating system. As we are aware, ESXi core component is vmkernel. Apart from vmkernel, there are some components inside the ESXi operating system, same like our traditional operating system, Windows, Linux, and Solaris. And once we familiar with architecture and components, we can focus on the log files and most commonly used commands. Reason is to learn about ESX log files is it will help us which log files to review and when in case of any issues are occurred in the ESXi layer. And ESXi commands also it will helpful for us to isolate the and also during the troubleshooting scenarios. And the configuration files form the backbone of the troubleshooting sessions. So let's start with the ESXi architecture now. So as we aware, in order to install the ESXi operating system, we need a one hardware. So this hardware can be any of the supported hardware models like HPE, Dell, IBM, any of the other third-party vendor hardware. On top of the hardware, we can install the VMware ESXi operating system. It's a type 1 hypervisor. Using ESXi operating system, the benefit of ESXi is using this ESXi hypervisor, it allows you to create a multiple virtual machine. And when we create a virtual machine, even the virtual machine means it looks like a physical machine. It's a software generated machine. It allows you to install a guest operating system and applications. That application can be all our customer project related applications. This is the basic traditional architecture within our ESXi basic level architecture. Suppose if we elaborate this architecture, that is looks like this. Even to install the ESXi, we not only physical ESX hardware, we also need a physical resources. That physical resources can be multiple ESXi host hardware, and to communicate between the each and every ESXi box, we require some network devices like network switches, router, firewall, and load balancer devices. And also the storage, the physical storage also we required to communicate for the ESXi host. And also if you are managing a storage within the VMware perspective, we have a multiple storage options. We can use either fiber channel SAN, iSCSI SAN, network attached storage, or we can use a software defined storages like virtual SAN, and we can also use virtual volumes. So physical resources are common in ESXi architecture, but within the ESXi operating system, within the ESXi layer, this complete green layer inside, the main key component of ESXi or core component of ESXi is vmkernel. Okay, it's a virtual machine kernel. So because ESXi our host operating system is same like a POIX, portable operating system interface, VMware developed and they mentioned their operating system kernel name as vmkernel. Okay, and how our Windows system, if you want to access your Windows system through command line, we are using a normal command prompt. For Linux operating system, we are using a terminal. Same way for ESXi also, to talk to the VM kernel we require a ESXi shell. That shell is, we can also call it as local support console or local CLI, local command line interface. And within the VM kernel, we have a main components are common information model, in short form CIM, and VMware management frameworks are running. Okay, and in detail CIM and what is the of VM kernel inside additional components, I will show you in the following slide. And but understand from this architecture diagram is ESXi core component VM kernel. To access the VM kernel, we require a shell, and with apart from the shell, we also have some additional components, VMware management framework and common information model. In order to access the ESXi host, we can access using agentless system management and also agentless hardware monitoring, and we can also use command line interface commands for configuration. That means network configuration and storage management and support. Even if you want to export our ESXi support bundle also, we can export. When you connect to the ESXi using CLI, when you type the command vm-support command, it will help us to export the complete ESXi host support log bundle. Okay, and once the ESXi host is okay, implementation is completed. The main benefit of ESXi is it will allows you to create a virtual machine, and even not only one VM, you can create multiple virtual machine. Once we create a VM, it will allow you to install the guest operating system and applications. And as similar as how we deployed the virtual machines, we can also deploy on ESXi host. We can deploy the virtual appliances. Virtual appliances means it's usually like a OVA format or OVF format, open virtual appliances or open virtual format. Those virtual appliances also we can provision on a ESXi host. This is the high level architecture. So let me elaborate some more additional components in VM kernel in the following slide. Let's start with the virtual machine. As we are aware, the main core benefit of ESXi is it allows you to create a multiple virtual machine. And using this virtual machine, we can install all our customer project related applications. But to install the application within our virtual machine, first install the guest operating system, and it's supported for Windows flavors, Linux flavors, Solaris flavors, and even not only virtual machine, you can also install like a pre-configured virtual machine, either PVM or you can install a virtual appliances. But the core benefit of ESX is to run our all production related applications. Okay, but to run this virtual machine also, we require a ESXi hardware. That hardware is nothing but a server hardware. Let's say I'm taking a one server hardware, but normally if you have a hundreds of virtual machine, one host, one physical hardware is not enough. We need a multiple hardware boxes. Just for our easy understanding, I took the example of two physical hardware. Okay, and on top of the hardware, physical hardware box, like let's say HP Proliant server, if you want to install, we can install the ESXi operating system. As we verified in previous slide, the core component of ESXi is VM kernel, and if you have minimally two ESXi hosts and more than two ESXi hosts, like 200 hosts or 2000 ESXi hosts, to manage multiple ESXi hosts, it also require a additional component, that is a vCenter server software. And vCenter server software, we can also call it as VCSA. VCSA means vCenter server appliance. This benefit of vCenter server is it allows you to manage multiple ESXi hosts. This point we are aware. Now how we can manage the vCenter ESXi and how we can connect the ESXi and the vCenter is the main requirement is we require a Vim clients. Vim clients means it's like a vSphere infrastructure management clients or VMware infrastructure management clients. So using these clients, we can connect to the vCenter server and we can connect to the ESXi host. For example, here we have a three Vim clients. First one is vSphere client HTML5. Using the vSphere client HTML5, it allows you to connect to the vCenter server. If you want to connect ESX, we need this component. Either you can connect using Vsphere Client HTML5, or if you want to connect to the command line interface, we can use PowerCLI. Suppose if I want to connect only directly to the one single ESXi host, during that scenario, instead of Vsphere Client, we have to use Vsphere Host Client. Host Client means it's only allows you to connect only one ESXi host. And how we can connect is you can just open any browser like Microsoft Edge, Google Chrome, Mozilla Firefox, any of the supported browser, and type ESXi host IP address. It will launch the vSphere host client page. So while login to the ESXi, we can use the login and password like root and assigned password. Okay. And similarly, if you want to connect to vCenter server, we can use vSphere client HTML5, and login credential for vCenter server is default administrator is administrator@vsphere.local, and you can assign the password. That's how we can access vCenter server and ESXi. This basic part we already aware, but now I am trying to elaborate some more additional points now. Let's say, and not only power CLI for command line access, we can also use secure shell, like we can use SSH session to the vCenter and ESXi host using putty. You can use the putty tool to connect to vCenter server. Just assign vCenter host name or IP address to connect to vCenter. Similarly, to connect to the ESXi, use the putty session and you can enter ESXi host name or IP address. Okay, until now we are okay. Now let's start discussing the additional point. And vCenter server, we have default vCenter server agent service. That agent service name is VPXD. D means daemon. So VPXD is nothing but it's a virtual center agent service. It's a main vCenter server service. And for ESXi level, we have the services are two services. One is hostd, another one is VPXA. Hostd means ESXi host level. We have a host agent service or ESXi host agent service. That agent service name is hostd. And similarly, when you add our ESXi host to vCenter server, vCenter also running ESXi host also running with a vCenter agent service name. That service name called VPXA. A means agent, but here VPXD means it's a direct to core vCenter server service, but A means it's a agent service. Okay, using VPXA service only, our ESXi host will connect to the vCenter server. Okay, and in addition, there are some agent services within our ESXi box. This ESXi also have additional agent service that is called FDM. FDM means Fault Domain Manager. This agent will start on ESX when we enable a vCenter cluster. Once you log into vCenter, create a cluster. Within a cluster, we have multiple features like HA, DRS, and fault tolerance. When you enable HA, high availability feature, high availability means continuous availability for virtual machines. When you enable HA within our vCenter cluster, let's say in our cluster, I have 3 ESXi hosts. All 3 ESXi hosts, it will allows you to start HA agent service. That agent service name is FDM, Fault Domain Manager. Okay, and DRS uses vMotion technique, and fault tolerance is it provides a zero data loss and zero data protection. Okay, this is some additional points. Now let's talk about another point is VMX process. VMX process means virtual machine configuration process, and also within our VM kernel there are some additional operating system components. How our additional third-party operating system Windows and Linux have a OS level core components. Similarly, our VMware ESXi also have a OS level components. It's almost similar to the other operating systems, Microsoft Windows, Linux, Solaris. But what is a normal operating system contains? Every operating system contains some resource scheduling. Even ESXi kernel also consists of resource scheduling. Resource scheduling means when ESXi start utilizing some resources by creating the virtual machine, the resource distribution is taken care by VM kernel. So that is called resource schedule. And also it is also taking care of IO stack. IO stack means input output stack. Most of the input output stacks mainly for network stack and storage stack. These two are the additional components within the VM kernel. Not only network stack and storage stack, within our VM kernel, it will also maintain some device drivers, that is like virtual NIC driver and virtual SCSI drivers, and also it maintains some VM kernel calls and DB filter. And apart from this, even VM kernel is compatible with our API calls, those calls like VM kernel API and interrupt handler calls. Along with this, there is also a virtual machine monitor. VMM also one of the part of the ESXi core kernel component. And system calls is also will help us to connect the ESXi host using user world support. Like if you want to access our ESXi host, we require a hostd service. And if you once you connect to the ESXi host using hostd, we can run the some command line commands like ESXi command and local CLI commands. Local CLI means it's is directly to run on ESXi, and ESXi command line is like a we can use to run our ESXi host update and upgrades, and also there is a some additional features in ESXi commands. I will explain you in the following slides. And user world support means instead of writing all the agents in the within the kernel, I just written in the left side to understand the connectivity process. Now try to understand the connectivity from all individual components. Now let's start with the vSphere client. Let's say vSphere client, as we discussed, vSphere client is always allows you to connect to the vCenter server appliance. That is a benefit of vSphere client. Now another component, Power CLI. Even Power CLI also allows to connect to the vCenter server. It is mainly for a command line access. Okay, Power CLI. And another component, vSphere host to client. Host to client means it allows you to connect only one ESXi host, but in order to connect the ESXi host, it has to accept the system calls via hostd service. If the hostd is running, our host client able to connect through the hostd, it will able to access the ESXi VM kernel. So that is the access process. So vSphere client host can connect to the hostd, but recommendation is hostd always it should be up and running. And another connectivity is when the hostd is running, even using Power CLI also we can connect to the ESXi host via command line. Okay, and another command line method is we can use, even if you want to add our ESXi host to vCenter server, one key service is VPXA should be up and running, virtual center agent service. And even if you want to enable a HA server, HA configuration during cluster configuration, when you enable HA, FDM service also start communicating to hostd. And another one, if you want to access command line same like Power CLI, we also have a putty session. Using putty also we can connect to the ESX CLI and local CLI commands we can access. But how it will run these commands is it will also start communicating to host agent service. But this hostd, how it will connect to the VM kernel is it will connect to the VM kernel through system calls only. And also it will also hostd taking care of virtual machine configuration processes or virtual machine monitoring processes. But all the system calls, it will start communicating to the shell and also communicating to the hostd, local CLI and all, it will start communicating. Okay, that is how the communication established to the our ESXi VM kernel. Now, even if you want to connect from ESXi host to vCenter, VPXT will start communicating to VPXA. If the VPXA service is not running, our ESXi host will not communicate to vCenter server. It may affect with a vCenter service is not running, so your ESX host also start disconnecting from the vCenter server. But the recommendation is this hostd and VPXA both services should be up and running. Then only our ESXi host is able to manage from vCenter server. Oh, other connectivity, even VMK API, it will start communicating to the physical hardware. Okay, all the interrupt handlers will communicate it to server hardware. And DB filter, distributed virtual filter, will communicate network stack. And SCSI filter also is virtual SCSI, iSCSI targets and all, it will communicate it to the input output stack. One is this storage stack. And even VM kernel calls also, it will handle interrupt handles and VMK API, it will communicate through VM kernel calls, and vmnic also will communicate it to the vmkernel calls. And all these architectural components I will explain again in the following slide. And virtual machine monitor, in short form we call it as vmm, and vmm also it will always send the communication to the vm kernel and vice versa. Okay, so this is how the ESXi architecture deep dive. But the main core concept here is we need to understand how we can access and what are all the key components in ESXi, and what is the agent services and main command lines which depends on ESX CLI and local CLI. Okay, now the following slide I will cover the individual components description. See, ESXi architectural components. So architecture components, as we discussed now, architecture compromises the underlying operating system called VM kernel and the process that run on top of it. VM kernel provides a means for running all process on the system, including management applications and agents. Agents we discussed just now. Agents are hostd, VPXA, FDM. These are all the agents. So as well as virtual machine, even it will allows you to run virtual machines. It has a control of all hardware devices on the server, manages resources for the applications. And the main process that run on VM kernel are DCUI, direct console user interface, and virtual machine monitor, and VMware agents, hostd, VPXA, and common information model, it is SIM system. Okay, this is the main component. And let me explain you in detail of DCUI VMM in the following slide. See, architecture components, DCUI means direct console user interface, low level configuration and management interface, accessible through the console of the server and used primarily for initial basic configuration. That means when you install ESX server in the initial setup, if you want to assign the IP address, VLAN settings and DNS and host name, all the initial configuration we can perform using direct user interface only. But how we can access the DCUI means, let me log into our lab system. Once we connect to the lab system, it's like a same like how we can access our remote system, how we can access same way. Let's say if I connect to our lab system, go to the vCenter. This is our vCenter. Let's say we have two clusters, one cluster running with the 3 ESXi hosts, another cluster is running with 1 ESXi host. But for ESX 1, 2, 3, these three are the nested ESX only. If I go to the summary, it is showing us VMware ESXi 7, and but it is running as a virtual machine only. But this virtual machine is running on our workstation VM. If I connect to our workstation VM ESXi 01, this is how our ESXi host screen looks like. Suppose once if you want to log into direct user command direct console user interface, this is only direct console user interface. Let's log into the ESXi password. So this is how the direct user control interface DCUI looks like. And here we can set the password, we can configure the lockdown mode, management IP settings and all we can configure here. But here in our lab system, I'm able to configure through workstation. But in our real-time scenario, if you want to access your HP server, you can connect through the ILO. From the ILO, you can access the DCUI. Suppose if it is a Dell server, you can connect to the Dell DRAC. IDRAC will help you to connect to the direct user interface, direct console user interface. Similarly, IBM means RSA, remote supervisor adapter. If it is a Fujitsu server, you can connect using a RMC tool, remote management console. You can connect to the Fujitsu hardware server remotely. Okay, and once you connect remotely, you can launch the remote console or remote virtual console. It will show us the ESXi host DCUI prompt. Okay, so now let me connect back to our slide. Let's minimize. So this point we're discussing now. DCUI, direct console user interface, low level configuration and management interface, and all the initial configuration we can do, we can configure through DCUI only. And the virtual machine monitor. And virtual machine monitor also it's like a VMM process that provides the execution environment for a virtual machine as well as a helper process known as VMX. Earlier in our architecture diagram, we talk about VMX. And each running virtual machine has its own VMM, virtual machine monitor, and VMX process. And VMware agents, as we discussed, hostd VPXA, used to enable high-level VMware infrastructure management from remote applications. And the SIM, it will also help to monitor hardware level monitoring. So interface that enables hardware level management from remote applications through a set of standard APIs. Okay, so let me explain some other components. So one main components for ESXi deep dive is vmkernel. This is the core component of ESXi operating system, and a POSIX, that means portable operating system interface, like operating system developed by VMware, which provides a certain functionality like that found in other operating system, such as process creation and control, signals file system and process threads, and designed specifically to support running multiple virtual machines. So ESXi mainly to run multiple VMs and provide core functionalities such as resource scheduling. So inside the VM kernel diagram, I shown you resource scheduling. IO stacks means network stack and storage stack, and device drivers. These are all the main components within the VM kernel. Now let's understand the file system. So VM kernel uses simple in-memory file system to hold ESXi server configuration files, log files, and staged patches. And the file system structure is designed to be same as that used in the service console of the traditional ESX server. And for example, ESXi server configuration files are found in /etc/VMware, and log files are found in /var/log, similar to other Linux flavored virtual machines, Linux flavored operating systems. And log files are found in /var/log/VMware, and staged patches are uploaded to /temp directory. And this file system is independent of VMware VMFS. VMFS means virtual machine file system, and this file system is used to store virtual machines. The in-memory file system doesn't persistent when power is shut down. That means even the power off, there will be no data disruption. Therefore, log files don't survive a reboot if no scratch partition is configured. VMware recommend that always configure a scratch partition. Usually by default, scratch partition is enabled. If no scratch partition, the data is not stored permanently. But how we can see the scratch partition is, let me log into the lab system again. So connect to the remote system. So when we connect to the lab system, yeah, this is our vCenter server. If you want to see the scratch partition logs, how we can connect is, just go to the data center or select any one single ESXi host, go to the configure tab. Under configure tab, you can look for a option for advanced system settings. When you see the advanced system settings, here you can search for a syslog. If you type syslog and enter, you will find a default scratch partition. See, syslog global log directory, it's supposed to be data store path. It's stored under the /scratch/log. If it is not stored in the /scratch and log, the logs will not store permanently. It will always log will be in the rotation mode. So VMware recommend to configure with this value only. This point only highlighted in the slide. See here, it's highlighted with this point. The in-memory file system doesn't persist when the power is shut down. Therefore, log files do not survive a reboot if no scratch partition is configured. Clear? Now the another point is ESXi can configure a remote syslog server and remote dump server, enabling us save all log information on external system. Always recommended to configure a remote syslog server. If you want to configure VMware official syslog server, that is a vRealize login set, VRLI. Or if you are using any third-party tool, also we can use centralized log server. Any LMS log management servers we can use. And ESXi deep dive user worlds. So within the user worlds, as we discussed earlier, the term user world refers to process running in a VM kernel operating system. The environment which user world is runs is limited compared to what is found a general purpose portable operating system interface compliant operating such as Linux. So the set of available signals is limited and the system API is subset of POSIX and slash processor file system is very limited, and a single swap file is available for all user world processes. If your local disk exists, the swap file is created automatically in a small VFAT partition. Otherwise, the user is free and set up a swap file on the one of the attached VMFS data stores. Suppose if you want to verify the VFAT partition, log into the ESXi host and we have to type the command df-h. That means disk free-h. When you type df-h command, you can see the small VFAT partition information. So if you want to validate VFAT partition information, let me connect back to lab system again. Okay, here, if you connect to our lab system, let's minimize here and connect to the ESXi host putty session. Let's open any one ESXi host. Let's say I'm connecting to one of the ESXi host, ESX04. So 10.74 connect. So enter the root credential, password. Okay, password is entered. Let me increase the font. Okay, now the font is increased. Let's say, let me clear the screen. If you want to verify the VFAT partition, type the command df-h, disk free-h. Now here you can see default VMFS, how many disk we have, all the disk VMFS volumes partition, as well as our boot bank partitions are stored in a VFAT, virtual file allocation table. So VFAT partition, small footprint. So this point only we are covering here. So automatically in a small VFAT partition. Otherwise, the user is a free to set up a swap file on one of the attached VMFS data stores. Either we can use automatic partition or you can use customized partition table also. Okay, that is the point here. And apart from user world process, there are some agents like hostd, VPXA, and FTM. I will explain you in the following slide. See, user world process agents used by VMware to implement certain management capabilities have been ported from running in Service Console to running in user worlds. The host agent process provides a programmatic interface to vmkernel. It is used by direct VMware vSphere client connections as well as APIs. Even application program interface also, if you want to connect our ESXi host vmkernel, backend hostd service should be up and running. It is a process that authenticates users and keeps track of which user and groups have which privileges. Okay, and VPXA, that is also virtual center agent. This process is the agent used to connect to vCenter. So our ESXi host, in order to connect to vCenter, VPXA service also should be up and running. It runs a special system user called VPX user. It acts as the intermediary between hostd agent and vCenter server. Okay, and FDM agent, fault domain manager agent, used to provide vSphere high availability capabilities, has also been ported from running in the service console to running in its own user world. Suppose if you want to validate this hostd and VPX, I will show you from the lab system where we can see the services. And even syslog daemon runs as user world. If you enable remote logging, the daemon forwards all log files to the remote target in addition to putting them in local files. A process that handles initial discovery of iSCSI target, after which point all iSCSI traffic is handled by the kernel, just as it's handle any other device driver. So this all the log information and agents information we can see from our home lab system. Just connect to vCenter server, select any one ESXi host and go to the services tab. Here you can see the our main agent services here. Let's say one of our syslog server service is running, and also CIM, common information model service also running. Currently it's a stop state. Even if you want to start, select this service, click on start. Okay, so that it will help you to monitor the hardware status. And another service, even ESXi SSH and shell and direct console user interface is currently running state. And if you want to see the hostd service, here hostd is not showing, only vCenter agent VPXi is showing. If you want to see the hostd service, again log into ESXi command prompt, clear the screen, and the command here is /etc /init.d /hostd space status. When you type this command etc initd and hostd status, it will show you as our hostd is running or not. Okay, that is how we can verify. And we verified hostd service. We verified the vCenter agent VPXA service, Syslog service also we verified. And even if you want to see the FDM also, we can verify from here. So FDM also, you can just type FDM status, you will find service is running or not. FDM, fault domain manager. See, FDM it's showing as not found. So that means the name will be, we can retype again. Let's say cd space /etc init.d and type ls. You will see what is the actual FDM service name. DCUI, SSH. For hostd, we have service here. Maybe the currently the cluster is not start with the HA. That is the reason it is not showing. vCenter agent is showing. If you want to see the HA agent, let me right click the cluster, go to the edit settings and enable HA. We can see whether the FDM service is going to start or not. Now I'm trying to enable HA. When we enable the HA, now we can see the service status. It will trying to start the FDM agent service here. See, configuring is in progress. See, you can see installing vSphere HA agent. See, agent is going to start on. See, now you can see here, vSphere agent is running here and it's not yet started. Even if you want to start, just start. It is showing some error message. Reason is shared storage is not yet configured. That's the reason it is showing the red color error message. But our point here is when we enable cluster HA feature, it will start with a HA agent service. That is backend the service name, we call it as a FDM. See, HA agent, it is in the running state. Okay, that is a key point here. So we verified hostd, VPXA, FDM, and Syslog. All services we verified from vCenter server. Now let's talk about the other point. ESXi deep dive DCUI. So DCUI is a direct console user interface, local user interface that is displayed only on the console of an ESXi system. So we verified the our lab system ESXi console, how it is looks like, and it provides BIOS like menu driven interface for interacting with the system. Its main purpose is initial configuration and troubleshooting. Okay, and the DCUI configuration task include set administrator password, set the lockdown mode, and configure and revert networking task. And troubleshooting tasks include perform simple network tests, view logs, restart agents, and restore defaults. So these troubleshooting options we can see from the default vCenter server DCUI prompt only. Okay. Now let's verify the another point. ESXi deep dive open network ports. See, within our ESXi level, we have the main ports are 80, 443, 5989, and 902. These are all the main ports. Many other ports also we have. That is depends on when we enable HA and vMotion. For example, if you want to enable vMotion, the default port is 9000. Okay. So now let's talk about the ESXi troubleshooting log files. So when you are troubleshooting ESXi host, log files also plays a major role. So vSphere offers a variety of features that enable us to collect and search log files. So log files are useful when trying to resolve vSphere issues. So if you want to see the log file information, change the directory to /var/log. It's same like our Linux flavors. So within our /var/log directory, when you type list ls command, you will find all the log files information. Okay, but with interest of our time, I will cover main important log files now. Okay, so if you want to see this log file information from our lab system, let me connect to lab system again and open the command prompt. If you want to see, just clear the screen, cd, change directory. The only option to verify this here log files is you can first change the directory to /var/log, enter. Now type ls, you will find all the list of logs information. So within these logs, we will not use all logs every time. The main useful log is vmkernel log is one of the important log, and vmk summary also important, and vmk warning also important. And another key logs are sometimes we also use hostd-log and vpxa logs also. So hostd-logs also you can find here, and even fdm log also important. Okay, this log information I will elaborate now. So that point only covered here. So what is the main logs files are available. And another point, viewing the log files by using DCUI, even direct console user interface also, we can view all our system logs. Even here you can see the main log files are 6 log files: system log, syslog, vmkernel log, config log, and management agent log. That means hostd log, vcenter agent log, vpxa, and VMware ESXi observation log. Observation log means VOBD. That is a shortcut word, VOBD log. These 6 logs we can verify. Even if we want to verify from direct user console, you can verify and you can type Q to return to the screens. So the direct console user interface can be used if the vCenter server is not available. Normally these log files we can connect to the console and verify either GUI mode or command line mode. When the vCenter server is not available, that scenario only we can connect to the DCUI prompt. With the DCUI, only the log files for single ESXi host can be viewed. So this portion I will show you in our lab system, how we can go to the view system logs step. Let's say connect to one of our lab ESXi host. For example, I'm selecting a ESX3. Just press F2 and type the password. Excuse me. When you type the password, you can see the system customization. Within the system customization, you can just drill down and you can see one of the look for the option is view system logs. So this view system logs only I captured the screenshot in our slide deck. So here you can see all the log files information. Same way for other ESXi host. Okay, either you can see from direct console user interface or the same log file you can see from our SSH session. Another method is we can also see from a vCenter level also. Currently shared storage not configured. Let me turn off the availability just for temporary. Once I configure shared storage, I will re-enable HADRS. Okay, here the log files, if you want to see the log files within a vCenter also we can see, just go to the menu. You can see task, events, and even if you want to export for a single ESXi host logs also, just right click here, we have an option for export system logs. This is also graphical user method, how we can export and review the log files. Okay, so this point also clear. Now let's talk about some other common log files. So as I mentioned, there are plenty of logs, but I am just trying to highlight few logs here. So authentication log, auth.log, it's mainly for ESXi shell authentication success and failure. And ESX update log, ESXi patch and update installation log, and hostd log, host agent log, if any kind of communication issues, host not responding or host is unreachable or a host is unaccessible, any scenario, we can review the hostd log. And the syslog .log. This is also mainly to management service initialization, watchdog, schedule task, and DCUI use. And vmkernel log, this is also one of the important log. And core vmkernel logs, including device discovery, storage, and networking device and driver events and all, we can find in the log. And vmk warning, most of the warnings are you can find in this log. And vmk summary, summary is like a host startup shutdown, that information only we can find here. And VPXA, virtual center agent, so it is also consist of all the communication related information from ESXi host to vCenter server. And FDM means it's a HA agent log, so it consists of all high availability logs produced by FDM service, fault domain manager service. Now let's also I'm trying to explain very important logs in the following slide. Let's say VMK summary. Suppose if I type a if I want to view the VMK summary log, it will allows you to show us any of the unexpected host reboots. So timestamp also it will shows when the host was rebooted. Suppose in this screenshot I captured for randomly two screenshot. One screenshot is showing us June month when the host is rebooted and when the host is booted. And same with today's screenshot also, when the host is booted and when the host is up. So that is called timestamp indicating host server reboot. And VM kernel will always track host boots and disable the automated system server recovery feature from the BIOS to avoid automatic reboots. If you want to view this log, just log into our lab system. Let me show you. Suppose connect to the command prompt. CD. Okay, anyhow, it's required to change the log to the var.log only. Let me clear and retype again. Change directory to /var/log. And now ls. Here our main log file now we are planning to use is vmk warning or vmk. Which log we are trying to use is it's a vmk summary. Okay, sorry. Let connect and type vmk summary and now press enter. When you type vmk summary, press enter, you can see here, look for a host booting, host rebooted, this information you can see. What is the benefit of this log is, let's say your ESXi host is unexpectedly restarted, but your customer wanted to know the root cause, when this host was really restarted, when it is come up. So that information you can find from the vmk summary log. So to view the log, just you can type the command cat space that specific log vmksummary.log and look for the timing information. Usually this log consists of a UTC time. For UTC time, you can just add based on your country. You can just add UTC time 0 to specific your time zone. You can add, you will find the actual time information also. So this timestamp we can find from a VMK summary log. And let me show you the another one. And boot.gz log. Normally this log file is mainly useful for slow boot issues. Sometimes customer is complain that after the ESXi host patching, our technical consultants or any of our end user may notice that our ESXi host rebooting taking longer time. So if you want to analyze that information, we have to use this log file. That log file location again, same location /var/log boot.gz. If you want to see the log, just go to the our lab system. Let me clear the screen and type ls. When you type ls, you can see look for a boot.gz log. This is the log. Okay, this log only I'm talking now. So this log will help us to show why to troubleshoot both slow boot and boot process hang. These two scenarios we can refer this log file, okay, to find the clues. And another method is even we can use direct console user interface. You can press the keys alt plus F12. When you press alt plus F12 also, you will find VM kernel messages. This message will also show you actual error information. So either you can go through the boot.gz log. Another method, go to the direct console user interface and press alt F12 to find the actual error message from the ESXi host direct console screen. Okay, I will show you this how I captured this screenshot. I will show you. Let me log into the vCenter and connect to our direct workstation ESX2. Let's say I'm taking the ESX2. If you want to press alt F12, first enter the password, and in our keyboard we have to type Alt F12. When you type Alt F12, it will immediately back to the vmkernel log screen. See, this is a vmkernel log screen. When I press Alt F12. So here, if there is any error messages and all, we can read from the screen. You can capture the screenshot and send it to your team to analyze it further. Sometimes even VMware technical support team will ask us to share the screenshot to analyze further. Okay, so that is importance of the screen. Or for most of the ESXi host hang or ESXi host slow bootness and all, we can refer like this. Either you can use direct log information or another method is Alt F12. Any method we can follow. Okay, so this is a one type of troubleshooting scenarios. And another scenario, let's say some most common ESXi issues are ESXi host not responding. Even for not responding scenario also, we need to validate two logs. One is hostd log, another one is hostd-probe.log. These two logs also stored default location is /var/log. When the hostd unresponsive, the host not responding from the vCenter server. So a successful hostd process startup or working fine, hostd process should finish reading and populating with VM inventory.xml file. That is a usual process. And direct connection to the ESXi with host client should also validate the hostd process. If you want to access ESXi host from vCenter or direct host client, always backend in processes host agent service should be up and running. Don't restart ESXi server when hostd is in a loop if we need to pursue the cause, because sometimes customer may ask ESXi host not responding, they want to know the root cause. During that time, before finding the clues, don't restart the hosted service. That is the point here. If you restart the ESXi server, and we may miss to find the root cause. Okay, and understanding the hostd status and validating the hostd service restart is successful. And hostd service restart, if you want to restart also, the restart procedure is simple. Just log into our vCenter server using SSH session and type the command /etc/init.d hostd status. When you type hostd status, it is showing as permission because we are in a log prompt. So type cd and again retype the same command /etc/initd hostd status. It is showing as permission denied. Okay, that means we have to put one more slash here. I missed to keep the slash. Okay, /etc/initd hostd status. When you press here, you can see hostd is running. If you want to restart, you can just change the same command. Instead of status, first you can stop and then start. That is one method. Or else another method I always recommend is just run the command restart. When you try restart command, it will stop the hostd service and it will start the service. Even if you run one more time also, no issues. Okay, now again run the status command. You can see hostd status is running state. That is how we can restart the hostd. But what VMware recommend is, if your customer is looking for a root cause, before restart the hostd service, first to verify the boot.gz log. That is one method. Or another method is log into your ESXi host direct console user interface, press Alt F12 to review the VM kernel actual error messages. Once you capture the error messages, then you can restart the hosted service, so that we are in control and we will find the root cause analysis for further investigation. Okay, now let me show you the some other steps. So this point is clear. Now there are some more ESXi troubleshooting commands. So those commands we can discuss now. Methods to run ESXi command is VMware vSphere ESXi shell, which includes ESXi command and a set of ESXcfg commands and a set of other commands also. Same like our Linux operating system, even if you want to find our ESXi host commands, connect to our ESXi host using command prompt and press double tap. When you press double tap, you will find all the ESXi host supported command list. So with interest of our time, I'm not covering all command, but when you have a spare time, if you want to research on individual commands, you can just type command space -h or -help to get all the help information. So through that help information, you can try to enhance your skills on specific to the command line interface. I will cover today only the most commonly used commands. Okay. And now here is how to monitor and configure ESXi server settings. Here also I'm taking a 6 scenarios and the main command is ESXi. So using ESXi command, we can connect to the storage. Within the storage, we can get all these details, vSAN, vwall, vmfs. That is a one scenario. And even using ESXi networking commands, using CLI system commands like boot, module and process, same way software and same way vSAN and also the VM. Let me show you how we can monitor and how we can configure the ESXi server settings now. Let's connect to our any one ESXi host using SSH prompt. Let me clear the screen. If you want to know all the command list, just press double tab. We can see all the commands information. These are all the ESX supported commands. Okay. So suppose specifically if you want to see the ESX CLI commands, let me clear the screen. Type the command ESX CLI and again press double tab. You can see only ESX CLI and ESX CLI Python script. Now if I press enter, you can see ESXi help information. See these commands only I've written in the diagram. You can run the ESXi vSAN command, ESXi VM command, system, storage, software, network, iSCSI, this and all I've written in the diagram. Suppose if I want to see the last one, vSAN commands, just type the command ESXi space vSAN. When you type vSAN, it will show you some other options. Even after the vSAN, this is a syntax. You can type vSAN, again you can type command and command options. Suppose if you want to verify any of the options, uh, usually in our previous versions, ESX6 series, we do not have a vSAN facility. Even from ESX7 onwards, VMware introduced to use vSAN ESXi command, and there are some two new features are included. Debug also we can run from the command line, and encryption also they given the options. Debug is for a debugging purpose, and encryption also available from vSAN encryption command. Suppose if you want to see that option, ESXi vSAN space and we can run the command debug. When we run the debug, it will show you again the command options. So command we already typed debug and even you can use the command option. That's how we can explore all the ESXi commands. Okay, how I am trying to type one by one, the same way you can explore the ESXi commands when you have a spare time. Okay, so now let's back to the other slide. ESX CFG commands, even CFG commands also same. The name itself says CFG means it's a configuration commands. When you type ESX CFG followed by tab, when you type tab twice, you can see the all these commands. See all the available commands. If you see all the available commands are advanced configuration, dump part, fiber channels over Ethernet command, hardware SCSI, all are related to the network and storage related. So remember, if you want to type help -h to provide all the commands help. Okay, and commands with ESXCFG hyphen prefix enables us to manage our storage, network and host configuration. This is also important commands. Okay, and now and there are some other effective commands for troubleshooting. ESXCLI just now we discussed. Apart from ESXCLI, we can also use vim-cmd command. This will also help us to managing ESXi server and virtual machine related configuration. And even for specific to the vmkernel sys information, there is a separate shell vsish. And vmkfs tools, this is also one of the important command. Using vmkfs tools command, if you want to convert your virtual machine disk from thin disk to thick disk or vice versa, we can able to perform using vmkfs tools command. So for management of vmfs volumes and virtual disk from command line. And memory status also, if you want to run, we can use memstats command on a specific ESXi host and packet capturing -uw. Even this is also, suppose sometimes any of the virtual machine from source ESX to destination ESX have a intermittent connectivity issue. During that time, if you want to enable your packet capturing from source to destination where our real network issue is happening, that scenario, that troubleshooting scenario, we can use this command, sixth command, packet capturing. Okay, and ESX stop. This is also one of the important command to run for a real-time performance monitoring. So let me show you these commands in our lab system. Let's say earlier we run the ESXi, even ESXCFG also. Suppose let me clear the screen. ESXCFG hyphen. Now press double tab. It will showing all the ESXcfg supported commands. Okay. If I want to see the any NICs information, let's say ESXcfg hyphen NICs space hyphen L. It will show you all your NICs list. Currently in our lab system have only one NIC. Link status is up and speed also okay. Okay. And the same way you can run the other commands also. And suppose other command is like vim hyphen cmd. It will also show you if you want to see the virtual machine list, you can run this command. It is showing as, let's say, display the help page or V for a version information, host name. Okay, we can see the any of the option and run here. So VM hyphen CMD space, let's say hyphen V version information. We can see our ESXi host version information is 7.0.update 3 build version. Okay, so that is a vm-cmd command. And same way esx top, if you want to run esx top, you can run esx top. You will see all your esx host task performance, cpu performance, memory, disk and all. It's the same like our windows have a task manager. Same kind our esx host also showing for performance monitoring. We can use the command esx top. Suppose if you want to see specifically to the cpu, memory, disk and all, we have to use shortcut keys. Let's say for a disk information, just press when you type ESX top command, press D on the screen, you will see only the disk related like VMHBA information. Again, if you want to see the memory information, type EM. You will find all the memory statistics information. Okay. Same way, if you want to see the CPU information, type C. You can see all the CPU statistics information, CPU run, CPU wait, all the information, CPU ready, ideal, all information you can see. And same way for storage utilization, you can just press U on the screen. You will find the storage disk status. Currently, shared storage not configured. It is showing the local disk information. Same way, if you have any vSAN, press X. Currently, vSAN is not configured. That's why it is showing the empty. And similarly, if you want to see the network information, press N. You will see all the network vmkernel, vmk NIC, network configuration. So these shortcut keys are important. I will show you in the slide also what is the keys I use now. Okay, and another key is suppose for power information P, all your ESXi host power statistics information. And same way for virtual machine information V. Currently only one cluster VM only running. Okay, that is importance of ESX top command. Let's back to the slide. See, ESX top is mainly for real-time performance monitoring. See, if I go to that slide, how to monitor ESXi performance is type ESX top command. Specific to CPU, type the keyword C. Specific to memory statistics, press the key is M key, and disk HBA level information D, and for the storage LUN specific information U, and vSAN. This keyword letters need we have to remember. And network information vSwitch and uplinks, press the key N, and also power usage and management P. And now finally for virtual machine, press V. This is all the performance metrics when you are checking a ESX top command. Okay, and apart from this, there are some most frequently used commands. These all via vm support. This command is helpful to export the all ESXi host diagnostic data. And df-h we verified today disk free status. And even if you want some elaborated information, type vdf-h. And if you want to see the VM NIC status, this is the NIC status, vSwitch status using ESXcfg configuration commands. And same way network list we verified now. And even storage information also we can use ESXi command. And there are some additional important commands like part util command, even partd util-h. This command is helpful mainly for partition LUNs, create, resize, delete partitions. And voma-h, it is also one of the on-disk metadata analyzer for VMFS data stores. And ls/etc/initd, this one we tested with hostd service how to stop and restart. And same way we can restart for vpxafdm and all. And suppose if I want to restart all the services in my ESXi host, the command is services.sh space restart. These all commands are most commonly we are using in the real-time scenarios. Okay. Now Let me explain you ESXi troubleshooting. As part of troubleshooting, what is the main key configuration files? This is also important. When there is any ESXi issue happen, we also need to look into the configuration files. See, ESX configuration file default path is /etc/VMware folder, and within that folder we can see the configuration files. So ESX conf means it holds the ESX storage, network and hardware information, and for inventory is mainly for ESXi virtual machine inventory information, and hostd authorization, it's mainly for who is connected, who is accessing the ESXi host from vCenter. All authentication information we can find from the authorization.xml file. And VPXA, it's for a vCenter and ESXi host connectivity details. And iscsi.conf, it's mainly for iscsi configuration file, and FDM is mainly for cluster related information, and license.config file, consists of license configuration file for ESXi host. Okay, now until now, we covered the ESXi host, architecture, architectural components, log file, commands, and finally configuration files. So here is the today's takeaway: ESXi deep troubleshooting takeaway. These all the points are useful when you are working on ESXi host issues. ESXi, when the ESXi host hung, ESXi host unexpected reboot, ESXi host is not responding from vCenter, or ESXi host affected with purple screen of death, all scenarios these commands and logs are useful. It depends on the error symptom. Okay, so deep dive troubleshooting takeaway is, to improvise troubleshooting steps, we must understand ESX architecture from a component breakdown perspective. This portion we covered. And troubleshooting ESXi is very much the same way as any operating system. Like every operating system have a resource scheduling, even our ESXi also have a resource scheduling. Even every operating system have a IO stack. Even our ESXi also have a network stack IO and storage stack IO, and also it will also handle the API calls and device drivers, all information same like other operating system. Even ESXi also have the all capabilities. And start by narrowing down the component which is causing the problem. Even if you have a brief idea on ESXi architecture and component, it's easy to narrow down based on our error messages. Okay, and once you read the error messages, we can easily understand where the problem is resides. And ESXi log files also we covered, and most of the log files are stored under the /var/log directory. And which logs we review and all, I covered basic few logs just for our easy understanding, and rest of the logs you can just explore. Okay, and ESXi commands also, we explored few commands like ESXi command, ESXcfg command, and ESX top for performance monitoring. And I also shown you main keywords for CPU, C, memory, like that. Okay, and the configuration files we discussed. Configuration files also important when we are doing a troubleshooting session. Any information is needed, we can find that specific ESXi configuration detail from the configuration file. So hope you understand the deep dive troubleshooting scenario. Okay, and if you have any questions and all, you can just send an email or a update in our video comment session. Okay, so that I can respond accordingly. Okay, that's it for today. Thank you. Please do view, like, share, and subscribe to my channel. Thanks for your support. Bye for now.